We're going to wait a couple seconds for a few of you to get back to do this section 1.5. Section 1.5 deals with interval notation. Interval notation is a shortcut way of us dealing and writing our answers that have greater than and less than in it. There are three ways to show an interval. If I just write down x is greater than 3, then that means it's everything to the right of 3. But I can show you that same idea. Put a number line, start at 3, and then you move to the right. X is greater than 3, and what I just shown you on this number line says the same thing. Now I want you to be careful. I use the parentheses there. If I have almost the same problem, if I have x is greater than or equal to 3, you're going to go the number line, but this time at the 3, I'm going to put a bracket. The bracket says that it's included, that x is greater than or equal to 3. Now, makes good common sense. If I tell you that x is less than 5, we're going to put our number line. We're going to start at 5, and then we're going to come back to the left. So I can show this with an inequality, x is greater than 3. I can show you the same idea on a number line. And then we also have that I can show it as an interval notation. So if I got x is greater than 3, and I want to show it as an interval, I use parentheses 3, and then I go to positive infinity. Now, I'm not sure a course compass writes to positive infinity or not. They don't have to. When it's positive infinity, you don't have to say that it goes to that. Make sure that you write your answers the way that he says it so that you'll get credit for your problem. Now, I want you to notice the difference. This x is greater than 3 with interval notation. I use the parentheses. The parentheses always goes with infinity because infinity has no end. If I have x is greater than or equal to 3, then I'm going to start with a bracket and I'm going to go to infinity. Now, I want you to notice the difference between these. X is greater than 3, you're simply going to use the parentheses because the 3 is not included. When x is greater than or equal to 3, you have to use the bracket to show that it is included. So if I give you one like this, three is less than x is less than or equal to 5. Well, let's put it on a number line. This is 0, this is 3, and this is 5. Well, it's greater than 3, so it's going to go to the right of 3. It's less than 5, so it's everything between 3 and 5. Now, I'm making a big deal out of it because it is a big deal. The parentheses goes with the 3 because it's not equal to. The bracket goes with the 5 because it is equal to. Now, so if we're going to write this as interval notation, it's simply going to be parentheses 3. It's going to be bracket 5. Now look at the 3. All three of these things are saying the same thing. 3 is less than or equal to x, is less than equal to 5. On the number line, you put the parentheses with the one that's not equal to, you put the bracket with the one that is equal to. When you write it in interval notation, you do the same thing, the parentheses with the not equal and the bracket with the equal. So this is the whole idea of interval notation, and that's basically what this section is about. The very first class, we saw linear equations. Well, we can solve linear inequalities also. So if I tell you that x plus 3 is greater than 8, now that's linear. It's linear because the x is to the first power. In fact, we're not going to do any inequalities that aren't linear. It gets a little bit complicated with that. We're going to do the same thing we did the others. We're going to add, subtract, multiply, divide. So in this particular case, I'm going to subtract 3 from both sides. So x is greater than 5. Okay. So my answer, if I put it as an interval, I'm going to do parentheses 5, and I go to positive infinity. This means, welcome back, Alexander.
Hello.
You here?
Yes, sir.
All right. Let me flip back real quick to this last page so that you'll be up with me, but I suspect that you know all this already. We're trying to write stuff as an interval. So when x is greater than 3, if I put it on the number line, I put me a parentheses at 3 and move to the right because it's not equal to. If x is greater than or equal to 3, I put me a bracket at 3 and move to the right. What does a bracket mean?
Means it can't go any further down the line.
Right, back this way. But also it has another meaning too. You use the bracket when it's equal to.
Yeah.
You use the parentheses when it's not equal to. Fair enough?
Yes, sir.
Okay. And that's all this page is talking about. Let's look at the very bottom one on that page. I had 3 is less than x is less than or equal to 5. Well, look at it when I write an interval notation. The 3 had no equal with it. So it's a parentheses with the 3, but it's a bracket with the 5. Are you clear with that?
Yes, sir.
All right, let's move on to the problem now. The problem says that this is linear, so I can add, subtract, multiply, divide, but we're going to have one little quirk that we have to deal with, but we'll deal with that in a minute. So the first law is this. I can add and subtract, and it doesn't bother anything. I repeat, I can add and subtract, and it doesn't bother anything. So if I got x minus 6 is less than 8, then if I want to solve that, I'm going to add 6. So I get x is less than 14, right?
Yes, sir.
Now, so if I'm going to show me x is less than 14, I'm going to come back here from negative infinity, and I'm going to go to 14. Now, I made a statement earlier. When you have infinity, you always use the bracket because infinity is not a definite number. Now, I use the parentheses with the 14 because it wasn't equal to. Fair enough?
Yes, sir.
Okay. And the same song and dance as that first lesson. If I tell you that I got x divided by 5 is greater than 2. Well, to solve that thing, I'd multiply both sides by 5. And the reason we do that is that this cancels. So I get x is greater than 10. Is that all right?
Yep. Yes, sir.
I tell you what, let's just move us an equal to in this thing so we can change it a little bit. So this says then I'm going to put it as an interval, and I'm going to start at 10, and I'm going to go to positive infinity. Fair enough?
Yes, sir.
Okay. So that means that I can multiply both sides by the same number, and everything is all right. Do you remember what's not all right? How do you have to, when do you have to reverse the inequality?
Remind me.
When you multiply or divide by a negative number.
Oh, yeah.
Yeah, you have to be very, very careful with that. And let's take a perfect example of that. If I tell you that x is, well, let's say that I tell you that minus 3x is greater than 12. Now, before we work this mess, let's just try to pick some numbers that might work. If I let x be 1, it's obviously not going to work. If I let x be any positive number, it's not going to work. But suppose I let x be negative 5. How much is minus 3 times minus 5?
15.
Right, and 15 would be greater than 12. Is that right?
Yes, sir.
So it seems to indicate that we're probably going to have to get negative answers for our problem. Agreed?
Agreed.
Well, that's the kicker to this mess. So you copy your problem down just like it is, and you're going to divide both sides by -3. Now, when you divide -3 by -3, we get our x. Fair enough?
Yes, sir.
Now, on the right-hand side, 12 divided by -3 is -4. Agreed?
Yes, sir.
Now, and this is the biggie. Look at it. My inequality, instead of saying greater than, it now says what?
Less than.
Less
Remember.
than. And that's all you got to remember, folks. When you multiply or divide by a negative number, you reverse the inequality. Everything else stays exactly like it was that first class. Add, subtract, multiply, divide to solve a linear equation. One more time. When you divide or multiply by a negative number, you flip your inequality. So this says the answer to this mess thing is everything less than -4. He makes you put some of the answers on number line. So if this is 0 and this is -4, then on the number line, it's going to look like that. If I'm going to write it as an interval, it's going to be from -infinity to -4 with the parentheses. And we use the parentheses because this thing is not equal to. That makes sense?
Yes, sir.
And the same thing holds for multiplication. If I've got -x divided by 3 is greater than negative, or let's say 2, make it easy on ourselves. So this time, in order to solve this thing for x, we're going to multiply both sides by -3. The reason we're going to multiply by -3 is because negative times a negative gives me positive, right?
Yes, sir.
So this says that x is going to be less than 6. Now, one more time, we multiply by the -3. So what do I have to do to my inequality?
Reverse it.
I have to reverse it. So the answer is x is less than 6. Let's just give it a try. Let's pick any number less than 6. Well, isn't 0 less than 6?
Yes, sir.
So if I put 0 up here, 0 divided by 3 is 0. Isn't 0 bigger than -2?
Yes.
Yeah. So it works, and it works every time. So all you got to remember is that when you multiply or you divide by a negative number, you reverse that inequality. And we can soup it up a little bit, but it's still the same song and dance. Let's try this. So I got 6x minus 11 is less than or equal to 1 plus 5x. Well, the big deal is we can add and subtract like we want to. So I got 6x minus 5x is equal to less than 1. Bring the 11 over, it becomes positive. 6x minus 5x is x. On the right side, 1 plus 11 is 12. So my answer is x is less than 12. It's that simple. It's the same thing we did the first lesson. The only difference is you have to worry about when you multiply or divide by a negative number. You reverse the inequality. Fair enough?
Yes, sir. And this would have a bracket, obviously, on a line.
All right. If I write this in interval notation, then we're going to put from -infinity to 12, and I'm going to put the bracket on the 12. Fair enough?
Yes, sir.
And the rest of it is almost the same. As I guess we need to do one with a fraction in it just to practice with fractions a little bit. I got 1/2 is less than x plus 1 divided by 5 is less than 5 divided by 3. Apparently, I copied that one straight out of homework. I wouldn't have made it that bad. What's my common denominator for 2, 5, and 3? Wouldn't it have to be 30?
30.
Yeah. So that means that we're going to take everything we got there and we're going to multiply by 30. I got 30 times 1/2. I got 30 times. And I got 30 times 5/3. So the half cancels out, so I got 15. Now the 5 goes into the 36 times, so I got a 6x plus 6. And the 3 goes in 30 10 times, so I got a 50. Now, watch what we do with this mess when it's hemmed up in between them. We're going to keep the x in the middle. So we're going to subtract 6 all the way across. This is going to give me a 9. This leaves me a 6x. And this leaves me a 44. Now, we're going to divide by 6. So I got 9/6. I got an x. And I got 44 divided by 6. So if I write it as an interval, it's 9, 6, 44, 6. Why did I use the parentheses on both of them?
Because they're not equal to.
Because it's not equal to. You don't.
So this is just the exact same thing, just with the inequalities.
That's right. That's exactly what it boiled down to. Except this time you're leaving you're not making two problems out of it. You're leaving the x in the middle.
Yeah.
You're taking a shortcut. Okay. All right. One more. One more says this. I got some test scores. I made a 92, an 80, an 88, and a 94. Those are my first 4 test scores. The question is, what do I have to make on the last one to make at least a B? Well, we're on the 10-point system, so that means that to have a B, I got to have an 80. Is that right?
Correct.
Okay, so the last one, let's say that it's X. We don't know what it is. And the way you get averages, you add all your tests together and you divide by how many you took. Is that right?
Yes, sir.
So in this case, we took 5. Now I want to get a B. If I want to get a B, then that means that it has to be greater than or equal to 80. Does that make sense?
Yes, sir.
Okay. Do you happen to have a calculator handy?
I do. 92 plus 80 plus 88 plus 94 is 354.
Man, I'm glad you came through because that saved me a lot of time. Okay. Now, I want you to look at this inequality that we got. We need to get rid of that 5. Is that right?
Yes, sir.
So I'm going to multiply both sides by 5. So 354 plus x. 5 times this is 400. Now I need to subtract the 354. Is that right?
Yes, sir.
So if I take 354 off of this, I got a 6 and I got a 4. So the answer is greater than or equal to 46. Now my question is this. How in the world could he make such a low score on that test and still keep his B? Look at your first 4 tests. 2 of them were A's and 2 of them were B's. Is that right?
Yes, sir. And then he gets a 46.
Yeah. So that means I don't have to do much at all on that 5th test in order to get that 80. Does that make sense?
Yes, sir.
All right. I'm sure glad you showed up, Alexander, and I'm just anxious to see if these things are going to be small enough for me to upload just like they are. Did you get my email talking about taking the quiz by Monday night?
Yes, sir.
All right.
And I believe that the ones you had uploaded already are working.
That's good to hear. Thank you for letting me know that. Have a good day. We're going to give this a try doing like we did here. Do it 30 minutes, take a 5-minute break and do it. And I think it's going to work. Have a good weekend.
You too.